don't you guys? All right. So right now we have project FPGA68k, then Padaloon, you're up after that, and on deck right after that, Big Alex. Are you in the room? Big Alex? Okay, awesome, great. So we've got our next speakers up. You ready to go?
Yes, I am.
Okay, your 5 minutes starts now.
Hello, everybody. My name is Tahsin-Bey, and I want to present one of my latest hardware developments. It's a small and cheap FPGA evaluation board. Next slide, please. A couple of months ago, I started to develop my own FPGA evaluation board with many simple interfaces on board that can be used easily, even by beginners. This board uses a modern Spartan 6 LX9 FPGA that can be supported by an external 68k CPU. The board can be built at home, but you should have done soldering fine pitch SMD before. Next slide, please. Here we have an overview of the board. The board has a standard VGA output. 12 bits are used for over 4,000 colors. It has a 9-pin joystick connector, according to the old Atari standard. Next to the joystick port, a mini DIN connector is located in case a PS2 mouse or a keyboard shall be connected. 2 independent serial ports, one according to the RS-232 standard. The other one is implemented as a USB port in slave mode. Furthermore, we have a static RAM connected directly to the FPGA. And I already mentioned the 68000 CPU that is also connected to the FPGA and to the RAM. The FPGA is clocked by an oscillator mounted on the button side of the PCB. The user interface of the board features 8 LEDs, 8 7-segment displays, 8 switches, and 8 push buttons. Next slide, please. All the displays, the LEDs, the switches, and push buttons are connected to the FPGA via a display driver that takes care of the LED multiplexing and the scanning of the switches. The display driver itself is controlled by SPI. The programming of the FPGA takes place by a 6-pin JTAG header. And for non-volatile storage, a serial flash is foreseen. Next slide, please. For your own extensions, there's a 40-pin extension header that can be used to connect your own circuits. Here you find 10 unused FPGA pins. Additional LEDs and 7-segment displays can also be connected here directly to the display driver. Next slide. The board itself is a 2-layer PCB with components on both sides. PCB size is 160 mm by 100 mm. To power the board, a stabilized 5-volt 2-amp power supply is necessary. Next slide, please. The status so far. VGA, serial ports, joystick interface, and the displays and switches have been tested and are working properly. The mouse and keyboard interface, the RAM and the CPU are next on the list and will be tested within the next few weeks. And up to now, I haven't had time for the website too. Next slide, please. Yeah, next steps. Finishing the tests and writing of a few Hello World designs. Launching the website FPGA68k.de. And finding of a few people willing to build this board. The cost for it would be approximately 120 euros. And as you can see here, your help in any way would be very much appreciated. Next slide, please. So, would you like to participate? Maybe you need more information. Maybe you are interested in building this board. Or would you like to talk to me about it? Then, next slide. Then please contact me. My name is Tahsin-Bey. This is my telephone number here at the Congress. This is my email address. Thank you very much for listening. Yes, of course.
Is this FPGA something you could use for fast processing of breaking keys or something like that? How fast?
Repeat the question.
I repeat the question. He's asking how fast the FPGA is. Up to now, a 25 megahertz oscillator is clocking the FPGA, but there's a PLL on the FPGA that can multiple the clock up to 100 megahertz, for example. But it depends on your design how fast the design can be clocked.
Great, thank you. And up next, we have Breno and Padaloon. Didn't get slides in, but they're going to go ahead and give a lightning talk without slides.